Hello, everyone, and welcome to our third breakout session. I just wanted to give you a quick reminder that these sessions are being recorded and will be archived and available after um, the summit today. I'm sharing some links for today's session in the chat for you, and I'll be posting them a couple more times as people enter the room. Please feel free to leave any questions that you may have in the chat, as we'll be taking a look at them throughout the session. So with that, I will go ahead and turn it over to our presenter for today.
Hello, I'm David Dobrowski. I'm going to do a demonstration and presentation about ggplot in R, and then talk some about the principles about visualization in general. So Andy just posted the links. They're also here for you to see, or QR code if that's easier for you. So as he said, I'm happy to take questions at any time all along. I'm going to try and keep the chat open, but also if you feel like chiming in, that's okay as well. So what I want to start with is first also just acknowledge that there's been a couple sessions about R in general today. A really good one that just ended by Ryan Eserata about R in general and how to use it. And then another one earlier by Oscar and Tyler that was a little more advanced, but still fairly introductory about how to do it in combination with MySQL. So to begin with, I want to know, why are you here today? So can we pull up a poll, please? So I want to know how familiar you are with R and ggplot. Okay. So mostly people who dabbled, a couple people that use it regularly, want something new. Again, please feel free to chime in with suggestions for the other people here. And thanks for staying, not just leaving. Okay. End the poll and move along. Okay, so to begin with, from a conceptual model, is like, why are we going to want to be doing graphing things? So one of the main reasons is when you're sharing out information, as many of you are familiar with, is there's this idea of a picture superiority effect. It says that when you have images that go along with the text or numbers that you have, people tend to remember it and are able to process it better. And so when we're sharing things with either administrators or families or the general public, it's many times very helpful to include graphs and pictures with what we're doing, along with the text and the narration of what's going on. Similarly, as we explore data, often you can see very different patterns develop with something that you can't see just with the statistical analysis. So this is a data set that shows a bunch of figures that all have the same X and Y means and same standard deviation and correlation. But as you can see, the patterns they create are very different. And seeing and recognizing these patterns can help people interpret what to do and how to do it with data. So we're going to look at the various components of a graph. A lot of this work originally came from Hadley Wickham's work with the grammar of graphics. His concept was that there's this underlying grammar for creating visualization and graphics, and that we're going to layer all the different elements on to make more complex visualization, similarly to the way we would add to a sentence to make more complex thoughts expressed in sentences and speech. And so I think this is a really helpful quote. The transferable skills from ggplot2 are not the idiosyncrasies of plotting syntax, but a powerful way of thinking about visualization as a way of mapping between variables and the visual properties of geometric objects that they can perceive. So as we create graphs, there's three main components that go into creating a graph. First is the data. You need some source for the data, and generally you're going to want it in a tidy format. So if you're familiar with the tidyverse, it's nothing new for some of the new people. or people are just starting to dabble, is the idea is that if we have a data set, we're going to have each column be a different variable and each row be a different case. So that way you are able to look at the data and use it to map to other things in an efficient manner. So in addition to the data, you need some sort of aesthetics. So this is the way, like, philosophically comes from the idea of the study of beauty and appearance, but it's really thinking about, like, how do we want our computer to make things look? Where is it going? How do we move from the data to the look and feel of the components? And then finally, it's going to the actual geometric shapes that you want to use. In many cases, these are going to be lines or rectangles or points, depending if we're making a scatter plot or line chart. You might be using maps. So those types of things and how they come together to make a graph, no matter where you're making a graph and how it comes together. In this case, we happen to be using ggplot as the tool to make the graphs. So again, just going through them, and I'm going to revisit this idea of these three different components a couple times today. So one is the data of what do you want to graph. So in R, we use this by using the ggplot command. Then the aesthetics of how are the different data elements that you're using going into the graph. We use this by adding aesthetic functions. And then the geom is the geometric forms that you want. And you do that by using geometric, geom underscore whatever you want. And there's dozens of them to use. Thinking of it another way is, like, there's all these different elements that we can use to put together. And what we're working on today is thinking about how do we write the script so we take these elements and put them together to convey a meaning or to explore data. So I'm going to start going through a bunch of code. The way it's laid out is I'm going to do something called, like, slow ggplot, where many times you put all the aesthetics into one function call, but I'm going to go step by step so you can see how it builds on each other and what the different commands do, so that in the future, when you want to do something, it might be helpful to look bit by bit of how it changes. So first thing we'd want to do is run the library. So in this case, either loading ggplot2, or if you load the tidyverse library at the start of your script, that loads ggplot along with many other things like dplyr, etc. So next, we're going to look at a data set. So in our case for today, we're going to be looking at the research files that come from the CDE that look at CASP data. See different codes for the counties, districts, etc. I filtered this already to only look at 5th grade test scores from the last year that it was done, so 2018-19. So the little percentage sign, greater than percentage sign, is called the pipe. It's a way that you move information from one function or execution into the next one down, so you don't have to keep saving your output and running something on it. So in this case, we're taking that data set and we're pushing that data set into ggplot. And so on the right, you can see our plot, which currently is just a big square because we haven't told it what we want to do. So the next thing we're going to do is we're going to add axes. So do this within the AES, that's the aesthetics view. And so this is how we're, as a reminder, mapping variables from our data set onto elements of the graph. So we're saying for Y, we want to use the column in the data set that is percentage standard exceeded. Then we're going to add another one. This time we're adding the x-axis, which we're going to use the mean scale score. I'm guessing most people here are familiar with it because it's California Education Data Science Conference, but just in case, there's two ways to look at CASP scores as to the standardized assessments that are being used throughout California. One, sometimes it's reported as the percentage of students who are meeting or exceeding the standard. Other times, the same data and assessment is used and reported in a way that's talking about there's a standard score, and then what each individual student scored is how many points above or below that standard they did, and then averaged across a class or a group. So there are two ways to convey information about the same test. And so what we're going to look at today is what is the relationship between the mean scale score and the percentage that actually I said earlier met or exceeded standard. In this case, we're just looking at the exceeded standard students. A little spinning wheel, so it won't go to the next slide. Okay, so as before, we talked about doing the ggplot function.
Apologies, everyone. It looks like we just lost our presenter for a little bit. If you bear with us, oh, there he's back. He should be up again shortly.
Hi, sorry about that. I am back. I'm going to stop my video to see if that is causing issues, but we'll start sharing my screen again. Were there any questions while I disappeared for a minute or two?
There was nothing in the chat even.
Okay. Can you, that's the one. Okay. Are you able to see the graph and code?
We're not seeing a screen, your screen right now.
Okay. How about now? Is that working?
There we go.
Okay. I'm sorry for all the delays, everyone. So as you said, we added a geom that, or adding points onto the graph. And so every point represents one of the variables in our data table. So then we're going to add additional aesthetics so we can change things about the way they look to convey information. So in this case, I'm going to change the shape of the different points to represent different counties. And so you can see, I just did the first 6 counties and the scoring. So it goes from Alameda to Colusa. Additionally, you can add more. So we can use color. So again, the idea is that we're using the data frame to map to different aesthetics based on the variable county code. So now you can see the color for every dot as a way to convey and see where they're at. And so, for example, county 3, I don't know what it is, but it's one of the very small ones because there's only 2 schools with 5th grade classes in it, or 2 districts. And so you can see where they are compared to 1, which is Alameda, has a wider array of schools. Adjusting the size, so you can see the size of the point varies in order to convey information that way. In this case, I'm doing number of students tested. Another thing that you can change is the transparency of the dots. So I'm doing you do that by using an alpha command to change the transparency. And so you can see the dots that are down here are really, really hard to see because I'm tying it to the percentage of standard met, whereas the ones up here are much clearer. You can also overwrite any of the variables you used before. So in this case, I'm doing color again, but this time tying it to something instead of the county code, I'm tying it to the mean scale score. Then I was like, the legend takes a lot of space. You can manipulate any aspect of the design you want to try and get to it. So again, looking at the components of it. Oh. Okay. The data, we use CASP data. For the aesthetics, we map variables such as county, which county, the number of students tested, their mean score, to the different components of variables for the graph. And for geom, we used a scatter plot. Going to move through another example. This is looking at a real school in California and their suspension rate over the last 10 years. So we take our data set. In this case, we're going to filter. So changing or reducing our data set, we only want to look at the reporting category of TA. And that means we're only looking at the set of students that are all students in the school. So we want to look at the overall suspension rate for the school. And we have it for California and this particular high school district. So we're going to pull ggplot. And then we want to look at it over time. So the x-axis is going to be academic year. And the y-axis is going to be the suspension rate. So we'll use a new geometry. In this case, we're going to use col. So it's going to create columns for a bar chart. Position dodge we'll get to in the next version of it, but it basically says if you have two different things, you want them next to each other rather than on top of each other. So in our case, now that I defined what group is, and it's going to be school name, it's saying, oh, you don't want to map California data and this high school district on top of each other, like you did here, where you would only see the higher of the two. You want them right next to each other. Then we'll add colors. So important thing to remember when doing things is that color is lines. So if you're doing an individual line jar, or in this case, it's the line around a bar, whereas fill is the inside color. Then we're going to add labels to the edge. So you can do this by doing the labels command and then typing what you want for label. You can see how it evolves. We'll add a source at the bottom. And then I move the legend from the side to the bottom. So this is the way you would build up a graph over time using connecting the variables with the different commands and options. Say we want to do the same thing, but we're like, oh, rather than do a series of bar graphs, it would be better to do this because it's over time as a line graph. So we can do that. Same thing as before. And all the same. So all of that was the same, except this time rather than the geom call, we use geom line. And that will create a line graph using the same data, the same mapping of variables as before. So one of the things that is very helpful in using R and ggplot in particular is if you want to go from a bar chart to a line graph, it's just one line of code in many cases to modify and change and adapt it. So that's really helpful that you can do that, is you can tweak individual parts and apply in other cases, or as you're exploring, change little things without having to go through and manually change everything by yourself as you would in Excel or elsewhere. Additionally, if you wanted to do this to make multiple graphs, we could just change our source, or like where we filtered for only all student groups, we could say, oh, we only want to look at female students and their expulsion, their suspension rate. So it would be changing one little bit of code. Could also do this for rather than one high school, all the high schools in the county, or something like that. Additionally, imagine like if your superintendent asked you to like change the color on one graph, it'd be really easy to, but then if you had to create the graph for every school in the county, the recreation is really where the scale comes into focus and what makes it really useful to use the coding rather than doing it directly. And if you want to share this, what you did with a colleague in the county or elsewhere in the state, they'd be able to run all the same code and create the same thing for their own situation without having to. So this case, we're going to do the same thing, but instead of filtering only for all students, I'm going to do it for each of the subgroups for this school. So there's no filtering. We're doing the exact same thing we did before in terms of X and Y. So this is what we're really adding now is a facet graph. Facet is the idea that you have the idea of like small multiples or many things going together that you are presenting that are similar. So in this case, as you can see, adding the facet split up to many different graphs based on all the different student groups. And then the rest of what we put in is going to be the same as we had it before with the line graph. In this case, I want to show a way to change the color. So in this case, the black line is the school in question, and the pink line is the state of California. And so you can see, looking across student groups, that there's a disproportionality in who is being suspended by this school and what is leading to such a high rate of suspensions. Then you can modify the way that the labels look. In this case, we're changing it from a decimal to percentage, so it looks cleaner. Add titles, captions, and then changing the names of, so before we just had the list of the variables, so we can change that to a neat looking thing for the labels. And then I'll touch on this in a little bit, but the idea of adding themes is rather than manipulating all these points bit by bit, it's a way in which you can take a preset theme, or you can create your own theme if you want everything that you make to look similar and represent your district or your county. You can develop your own theme, and then all the graphs will use that color template, that font, that arrangement for background, etc. So this is the way. So we're taking the same graph that we looked at earlier, and we're going to go through adding just different themes and see how that theme changes the whole lookout of the graph without going in. I see a question. I'm a stata user, so forgive any word verbiage. Definition is the variable that is grouping. Yeah, so that I'm going to go back to the facet one. Is the definition was the name of the variable that had the different student groups in it. And so when I did the facet wrap by definition, that was what it was sorting it by. This line here. That's how it creates the different ones.
I apologize. It looks like we lost David again. I'm sure he'll just need a minute or so to get back into the meeting. So please bear with us. Well, looks like we got David back. I don't think we have your audio, David.
Okay,
Oh,
I'm
there we
back.
go.
I'm sorry about that. I'm hesitant to share the screen again because it keeps kicking me out. Let me see if I'll stop my video. Are there any questions or things that I can address about R in general, about ggplot that would be helpful? Okay, I will try and share my screen, go through the rest, but I'm happy to have a conversation about plotting and coding, as that's helpful for others. Okay. So this is just the idea that it's the same graph, you alter the theme and it can change the appearance radically from how it looks. And so it's really helpful. My favorite theme to use is this theme HC. I find it very clean and neat. I like the placement of things. There's fewer things I need to mess with. Another idea is the idea of using color palettes. There's a lot of built-in color palettes. So in this case, you can use the command like scale fill or scale color, depending again if you're doing lines or filling in the color. And you can change all the colors. In this case, it only has 2, so it's not as dramatic, but it's an easy way to do it, particularly if you're doing something with many different colors in it. There's ones built in, like to begin with, I showed the colorblind one that have been tested. There's ones that are good for if you know people are going to be making photocopies and not using it on a computer for some reason, that transfer to black and white very well. Want to touch on this idea of principle of proportional ink, which is just the idea of you want to have as clean and neat of a graph as possible to draw people's attention to what's the most important thing for them to do. You don't want the viewer to have to spend a lot of time deciphering your work, and you want them to like use the data there to move on. And so as part of that, I really encourage you to eliminate clutter to help focus attention. Additionally, you can focus attention by using specific colors only if you want to draw attention to like one school compared to other schools, etc. A couple more resources that I find very useful. This is a PDF. It's not specifically about R, but it helps look at different types of graphs and when you would use them. For example, if you have discrete categories versus continuous ones, if you're comparing 2 things or 3 things or 1 thing, if you have text or whatnot. So I find this very helpful to help guide your way to choosing a graph. Our graph gallery is a wonderful resource. It is someone compiled a bunch of code for different types of graphs. So if you know what you want it to look like, but you don't know how to make it done in R, you can go look in examples, copy the code, and then modify it for your data set or your needs. A couple of book resources that I think are really good practical guides for people who are just starting out are Kieran Healy's data visualization book. It's all specifically about plotting and visualizations, and it uses R and ggplot as the example and tools that he uses. So that's very useful. Hadley Wickham's original one about elegant graphics talks more about the philosophy of using ggplot. It's a little bit more technical. There's also many others that are available if you just go to Bookdown and search for visualization tag. You'll find other books that people have published and shared there. In general, when you get stuck on things, I find searching on Stack Overflow is most helpful. Also, searching within the R community at community.rstudio.com, a lot of specific questions are answered there. So between those 2 resources, many times I can find the answers of what I'm looking for when things aren't working the way I want them to, or posting questions after trying multiple times. Another thing that can be helpful is Stephanie Evergreen has a data visualization checklist. It's about data viz in general, but it goes through different components of a graph, and it's helpful to look and think. It's like, okay, am I meeting these practices and suggestions about clear and informative data visualizations? And so there's a PDF that you can get from the link at the site where you can go through and rate each of the components, and then as you're going through an R, you can add or subtract things that you want to do related to that. Finally, I'd like to hear from all of you a little bit more. So this idea of learn, unlearn, relearn. Learn is something that's new from today. Unlearn is something that maybe you have been doing that you think you want to change or that you didn't like the way it was happening. Finally, relearn is a reminder of something that you may have done before that you'd forgotten about or want to bring back into your practice. So you could either unmute yourself or share in chat something you learned, unlearned, or relearned. I'd appreciate that. And if you have any questions or guidance for others in the room, that would be helpful. Thoughts from anyone? Well, we have about half an hour until the lunch session. I'm happy to stay if people do have questions, but other than that, you can reach me. Oh, I'll put my email in the chat as well. I'm happy to answer any questions about our studio and ggplot at other times as well. Sorry about the difficulties with being kicked off multiple times and freezing. Oh, thanks, Mark. I appreciate it. Yeah, I really appreciate hearing that. I thought that I like the idea of doing it line by line, so it builds up. So it's not as confusing, because I know many times you see the full code, you're like, okay, but what does this part do and what does that part do? And you have to break it down and mess with it. So that was the intent. And if you have questions about anything else as you're just getting into R, happy to help answer that, even if it's not related to visualization.
Yeah, David, I think I would just vocalize my thanks for your presentation. And the fact of the matter is, you know, for a lot of us, well, maybe not a lot of us, but this is kind of a newer thing. And as I said in my comment, I'm much more used to doing application development and full stack development. So just kind of seeing it in motion and getting to understand your thought process of how you added the lines was really effective. So I just appreciate the time that you put into it.
Thank you. I appreciate hearing that. Yeah, and as you're getting started, the other area that I think is really helpful for people just getting into it is looking at some of the commands under dplyr. That's also part of the tidyverse, and it's a way that a lot of the data frames are manipulated. And so being able to understand those functions and the manipulation for creating new variables or merging variables and filtering them out, I find like that's one of the most useful tools for people when they're first getting started. Yeah. Oh, and one more slide I got to. Just I do want to thank some of the resources that I use and people I help. So Evan Reynolds and Allison Hill helped inspire the way I did the slides today. And so that's really helpful and useful to see. And then the links to the original data files that I pulled from the state in the GitHub, there's links to the CSV where I just reduced it as for learning example. I'm going to share a different screen, just thought something else that is in the GitHub, but I didn't talk about today for the handful of people who are sticking around. Thank you. This is a file in the GitHub that just looks at the graphs themselves. So rather than the main file, the RMD is the creation of the slide deck. If you just want to look at graphs, there's a file called just graphs that gets rid of all the visual like slides. It shows loading the libraries and then 2 ways, loading the data is standard for everyone, but then 2 ways to make all of the graphs. There's the slow version where I add it line by line. And then I created another version that's more typical. If I was writing it for myself, this is the way I would write it. So you can see how that changes for each one.
Thanks for putting both of those in that source file. That's great.
Another thing you can do, I'm just thinking a lot from it, is you can store all of this as a variable. So now that's all stored at P. If you run P, you will get a graph. And then you can also add bit by bit as you want. So we want to add, we can flip it to the other way. So we're going to do flip. And so we run P plus this other function, and then I'm swapping my graph around. So you can, that's helpful if you want to iterate on a graph in many different ways, and you know you like part of it. Alex, Victoria, Andrew, anything that you're thinking about? Mark, you can share more as well, obviously. Oh, something that might be helpful is just talking through these libraries. The tidyverse is a very standard and very large library that is used for most my data analysis, and a lot of new development in R, I would say, happens in tidyverse. You can do things without it. It's called in base R, but a lot of the functionality, such as ggplot, such as using pipes, and the dplyr that I mentioned before to manipulate data are all part of tidyverse. The here library is useful in creating projects to reference your root directory of where the project is stored. And so all the files are stored within that directory. It makes it transferable to others, and particularly if you're sharing things on GitHub or working on multiple machines, it's very helpful. GG themes is a library that helps add a lot more themes that I presented before, of ways to configure and modify. It has a lot of popular media sources in there. So if you want to look like the 538 blog or the Wall Street Journal, a lot of those are from GG themes. Glue is a neat way to put things together. So if you have multiple strings that you want to put together for a title, Blue is the library that helps do that in an easy way. ggRepel has to do with labeling. And so if we look at this graph that we made here at the side, we wanted to put the actual suspension rate at the end. We could do that in normal ggplot, but on like the scatter plot where things are on top of each other, sometimes we want the label to move away from the point so it's easier to read and things aren't overlapping. And that's what that library does.
So David, can I ask a question about our universe a little bit?
Yeah, please.
So you mentioned that that tidyverse gets updated on occasion. Does that update automatically propagate to RStudio? Do you update RStudio and it automatically updates its libraries, or do you have to intentionally download them and install them and that type of stuff?
You have to intentionally do it. There's good versioning built into it, but it doesn't automatically do it, so as to not break historic code. But the way you would do it is if you want to update a particular package, you can go in and here, I'll click update and it'll go through and show you all your packages. I have lots installed, but it'll show the current installed version and what's available. In most cases, none of this is going to make much of a difference in terms of changes, but we can see all the ones that there is new version available for things.
Okay.
If it goes like many things in development, if this was going from like 1.05 to 2.0, I would want to make sure to read what is happening in the update. But like this change, I have no concerns about installing the update, and then I can just install it.
Gotcha. Okay.
And tidyverse library is a package of about 10 other libraries that are updated on occasion, and it's put out by the RStudio organization.
Okay. No, thank you for sharing all this. Really, really appreciate it.
Oh, and since some of the chats sound like a couple of people are fairly new, R is the language that's written in, so you'll need to install R, but RStudio is the IDE, like this interface that I and almost everybody uses when using R. And so that's available. RStudio itself is free open source, but they do also have like hosted options that you can buy into if you want.
I hate to capitalize on the time, but could I ask one more question?
Yeah,
so I was in Ryan's presentation.
Okay, great.
He was working directly in a Markdown file.
Mm-hmm.
Are you doing the same in this example that I'm seeing in front of me, or is this just kind of a source file and then you can make a Markdown file using the source?
So it's both. So let me show. I have this one, the one that ends in RMD. That's a R Markdown file. That's what I used here to create the slide deck. And so it can edit the code in here in these chunks. And then this part talks about the slides that's not in code. Whereas this one that ends just graphs.r is just a straight script. It's not a Markdown file.
And where do you tend to work, David? Do you start with the straight script and you kind of get those hashed out and then you start building your Markdown, or do you often work in a Markdown like Ryan was expressing?
Yeah, so I'm the one in the comments who said that I work in a script almost always first, and then I move it over to a Markdown if I know I want to present it in a certain way or share the format in a certain way.
Gotcha. Okay.
For me, I just find it easier. Like, it's not hard to make chunks, but I find it a little annoying to make chunks for different parts of the data set. And I forget like one of these weird little asterisks, or not asterisks, like slanty quote marks and stuff occasionally. So I find it easier just to run in here. And a good majority of my work is doing analysis for myself, and I need to do a lot of manipulation prior to creating a graph or something. And so in many cases, I'll just do it all in here and then save the graph. Oh, another function that just came to mind that's important to know is ggsave, which will save the last thing you did. And so you can either give it a thing. So we saved P as a plot earlier, and we can say example plot, and then choose whatever format you want it. And if you want, you can define width equals height or DPI. That's not how you spell height, but whatever. And then if I run that, oh, I restarted it. So because I updated the library, it restarts R. So now I'm loading my library, and now I can do my save command. I don't know what's doing wrong. Oh, it's because I haven't run any. It's sorry, I haven't actually done a plot, and I didn't save it. So my I'll do plot and so now it made a plot, and now I can go to my save. Sorry, I don't know what is going wrong. Normally that works fine. It's good to know. Sorry.
No worries. We've all been there for sure.
What else have you, or are you thinking of using R for?
I'm more in the curriculum line of work, and looking to develop some stuff for high school students, combining computer science and mathematics.
Thanks.
So just looking for what tools are out there and what's accessible.
Yeah, in the teaching format, it is easier to use the cloud version of RStudio rather than local installations in general, because then you can control what libraries everyone has, and you can easily push out a base script that you want people to work off of and modify for their own things if you're teaching 20 high school or something.
I'm pretty sure that Replit has an R instance that you can invoke.
I think it does too.
Yeah.
Yeah,
I'll just say thank you again for sharing. Much appreciated.
You're welcome. Victoria, your question, when you say move, that's just copy and paste. Yeah, it basically would copy my code chunk, like what I do in a normal script, and then put it in our Markdown file in these parts that say run the R code, and then in between it, I have stuff that I say like write my report and say like, today we are going to be talking about blah, blah, blah. And then in the chunk, I paste what function I want to run in R. Hi, Andrew.
Hi, I just wanted to chime in. Sorry, I've been quiet. I was supervising a room of kids, so I was listening intently, but I couldn't really speak. So
That's okay.
And so, but yeah, thank you for the presentation. Where I'm at is I'm really into data visualization. I'm a school psychologist, and so I'm kind of like always feel myself pulled into data. So I'm kind of like looking at what are different careers in educational data, especially in data visualization. So I'm just trying to get an idea of what the different tools everybody uses and things like that. So this was very helpful just to see behind the curtain of what you do. So thank you.
Good. Very happy to hear that. Yeah, and in response to one of your comments earlier about replicability being a big advantage, I find that to be a huge advantage. So like if you wanted to do something for every senior at your school or something, you could write the script, and then there's things to help you do it in parallel. So you basically, you'd have a data frame that would have every student as a different row, and then you'd either make a graph for everyone or calculate some function, and it would do it for all of them all at once.
Yeah, I could see that as a huge advantage. Just, I think of like my comfort zone is Excel, so I would think of like when you gave the example of the superintendent asking to change a color or something, to go change that like 100 times.
Exactly.
I felt that pain when you said that. So
Yeah, exactly. Doing that, or you did it last year in August, and this year in your August, you're like, what did I do? Like, I have the output.
Yeah.
There's no, like, this way it's really helpful to see your code, see what you did. You know, like, even if it takes a minute or two to refresh your memory and stuff, it's much easier than trying to recreate steps.
Yeah,
Well,
I definitely see that, and that happens to me all the time too. And so I just have to get comfortable working in this in code and this view. You know, I can, and it's just not how I visualize things. So, but I think just with tinkering, that's how you do it. So
yeah, I think. I don't know if you saw Ryan's talk at 10 o'clock.
No, I'm gonna go watch the recording.
Watching the recording of that would be really good. And then, yeah, playing and using other tools. I think trying in real use cases is often a good thing. Don't do something that's like time critical, because it'll take a lot more time as you're learning. But if you're like, oh, I really want to do something, yeah, it's very helpful.
Yeah, and I just envisioning my kind of personal development, I'm thinking is going and finding all these the public data sources, and just you know, building tools. You know, how would I use that, and just that way I can gives me real data to play with, but I can't break anything and can't expose anything. So
if many times, since it sounds like you're in a district, if you can do an extract from your SIS, that will have good real data that you can use too.
Yeah, definitely. So it's yeah, it's I feel like this is the next level. So thanks for sharing and sharing this.
Happy to.
Do you have any other general advice as far as like taking the leap more into data science, especially in education?
So for R, I'd say there's a book called R for Data Science.